Hello everyone. I'm sure that for this session, all of you are well prepared and waiting for this session energetically and enthusiastically. I hope you all have revised that unit circle completely, their special positions, PP dash, etc., and values of cosine and sine at particular positions. And in my another session, we had domain and range of sine and cosine functions. Also, we talked about other trigonometric ratio and the trigonometric identities. With all this preparation, now I move to this session. Now, you all must be wondering that how come I have not yet talked about graphs, because in all my lectures, my emphasis has been on graphs, and I have already declared that sine and cosine are functions, and the moment I call them function, obviously it is my prime duty to start with functions. And in this session, we will have only graphs of trigonometric functions and something related to those graphs. Now, first graph, before I start, understand that why are we drawing graph? Graph means there is one x-axis, there is one y-axis. If you recall, the x-axis was kept always for independent variable and y-axis was kept for dependent variable. If that is the thing, then I will have to check first which is independent variable and which is dependent. I have written as theta varies, x and y vary. Means what? X and y vary as theta varies. So x and y, they are expected to be the dependent variables because they depend on theta. And as theta varies, when I'm saying, that means you are allowing theta to take values as per your wish. And if that is the thing, then I must mention that theta is an independent variable. So one independent variable I have found and the dependent one also, that x and y coordinates are going to be as dependent variables. And what was x and what was y? X was cos theta and y was sin theta. So cos theta and sin theta would be nothing but dependent variables. Now as theta varies, sin theta varies, as theta varies, cos theta varies. So let us actually study them separately. That as theta varies, how sin theta varies. This would be seen on the graph of y equal to sin x. Now mind you please, at one point I said sin theta and theta varies. And now I'm saying y equal to sin x. You know what? Maths teachers are obsessed with x and y notation. So I write y equal to sin x. If you allow me, I can write y equal to sin theta also. And I will say as theta varies, sin theta varies. But by habit, we have been writing y equal to sin x. So please do not get perturbed because of that name x. X here is angle and you are applying sine on it and that gives you answer for y. Okay. If I had to draw graph, obviously I will have to draw x-axis, y-axis. I place origin also. And then I will have to mark those important positions like minus 3 pi, minus 5 pi by 2, minus 2 pi, minus pi by 2, minus 3 pi by 2, etc. All those angles, major positions I have shown. And then I try to see that how sine theta varies. And recall in unit circle what we had done. What was sine theta? Sine theta was y coordinate there. That means you change theta and see that new positions y coordinate and note it down. And theta and y coordinate, theta and y coordinate. Like that you make a table and then try to plot them here on these x-axis and y-axis. And you will be surprised to see that graph of y equal to sin x is like that wave. And I mean that sine values actually are showing you that how beautiful that curve is. And this curve you were not able to see on unit circle. I mean, how much ever I have been saying that unit circle is heart of trigonometry, but it is only, frankly speaking, to those who can study two things at a time. I mean, sin theta and cos theta, both you study on unit circle together. But if someone wants that, no, only one at a time I want to study, then best way is graph. You see this graph and you can see many things on that graph. Whatever I spoke on unit circle there, you can all actually verify results here. Like I said, sine of n pi is 0. And actually you check sine of minus 2 pi. Graph meets x-axis, means y is 0, means sine theta is 0 or sine x is 0. So sine of minus 2 pi is 0, sine of pi is 0, sine of minus pi is 0, sine of 2 pi, 3 pi, they all are 0. So sine of any multiple of pi is 0. You have also seen that sine at pi by 2 or 5 pi by 2, etc. It was plus 1. You can check that sine of phi pi by 2 is 1. Sine at pi by 2 is 1. See the vertical height at pi by 2. It is at 1 unit. So realize that sine theta is 1 at x equal to pi by 2. I mean, whatever you have seen on that unit circle, that you can see here in the form of a graph. So we can write here certain observations which are important and they should be noted at least once, I feel. First is sine function is increasing in 0 to pi by 2. As values of theta increase from 0 to pi by 2, sine values also increase. So we call sine function is an increasing function in 0 to pi by 2. Now you may wonder why I'm picking up only 0 to pi by 2. I can see that in minus 2 pi to minus 3 pi by 2 also. I mean the similar behavior. True. But from examination point of view, I'm saying that 0 to pi by 2 is pet interval of any examiner. So at least sine and cosine and tan functions behavior in 0 to pi by 2. Once you understand, then perhaps you can extend it to other intervals also. So I picked up only one interval. That does not mean that you will not be studying sine function in other intervals. Obviously, you will study. Now, I go to next and I say that sine function is a periodic function and period is 2 pi. We have already spoken about periodicity in topic function separately. What we mean by period of a function? That function repeats its behavior after a certain interval. And see, whatever behavior I am seeing of sine function in minus 2 pi to 0, same behavior I observe in 0 to 2 pi also. That one curve, one wave, I can see in minus 2 pi to 0 and also in 0 to 2 pi. And that tells me that after every interval length, 2 pi, function will repeat its behavior. And hence, I call that sine function is periodic with one period as 2 pi. Mind you, please, even 4 pi, 6 pi, etc. are periods. But I'm talking about here fundamental period. Fundamental period means least positive period. And that is nothing but 2 pi. Now, the way I have studied sine function, now don't you think we should study cosine also? So let us draw graph of y equal to cos x. Exactly on the same lines as we did for y equal to sin x. I draw x-axis, I draw y-axis, and then I place origin, x, y, name, everything. And the angles, the important positions. Minus 5 pi by 2, minus 2 pi, minus 3 pi by 2, minus pi by 2, etc. I mean, name all. As much, I mean, your paper allows you to do. And then, if you have to draw this graph, recall that unit circle exercise and understand that I would allow theta to change, but I will be observing only x coordinate of every new position which comes on my way. And I realize that values of cos theta means values of x coordinate there change, and as theta changes, they would look something like this. And this is also equally beautiful as sine curve. This is also a wave. Only thing is, it is a little shifted wave. That's all. But behavior is still same. So even some observations, what you make here, they are quite similar to the sine function. Except here in 0 to pi by 2, cosine function is a decreasing function. It is not increasing. Remember, there sine function was increasing. Here cosine function is decreasing. But cosine function is again periodic like sine function, and fundamental period here is also 2 pi. Now here at this point, I'm not giving you explanation. Like similar what we have done in case of sine function, you can build up your own explanation and understand that why cosine function is a periodic function with fundamental period 2 pi. Now, let me move to tan function. Mind you please, tan function we have not studied on unit circle. For this, you will have to make a separate table. One column for theta, one column for sine theta means y coordinate of unit circle. And cos theta means x coordinate. And then divide values of sine theta by cos theta and make one more column that would be for tan theta. And I draw graph and I realize again same way I will draw x-axis, y-axis, origin I will show, and I will mark those special positions minus 2 pi, minus 3 pi by 2, etc. But to my surprise now, tan theta is not defined at minus pi by 2 or minus 3 pi by 2 or plus pi by 2 or plus 3 pi by 2, etc. So here graph will not be existing, and hence I show them by dotted lines just to make clear that at odd multiple of pi by 2, tan theta or tan x does not exist. And when we divide values of sine theta by cos theta, and if I try to draw graph, These are the curves. I mean, those one branch each in the interval minus pi by 2 to pi by 2 or pi by 2 to 3 pi by 2. That one branch in each you are observing. And this kind of behavior on unit circle, you are not able to see. But in the graph, you can see, and actually, it's a beautiful thing to learn. What is beautiful thing about it? That it starts taking values from down, that is from minus infinity. Values of tan theta are from minus infinity, and they keep increasing and they go up to plus infinity. And hence, we had mentioned that tan function can take any real value, and range of tan function was nothing but set of real numbers. Now, can we talk about observations like how we made in case of sine and cosine? And they are nothing but tan function is also increasing in 0 to pi by 2 because I have kept that interval fixed 0 to pi by 2. And here tan function is also periodic function like sine and cosine. The only difference here is I said that what kind of branch you are observing in minus pi by 2 to pi by 2, same you are observing in pi by 2 to 3 pi by 2. So interval length remains pi, and hence fundamental period here is pi and not 2 pi. In case of sine and cosine, it was 2 pi. Now, basically, to me, actually these three graphs are enough that you remember sine, cosine, and tan. But those who are interested in knowing what about cosec, sec, etc., for them, for their understanding, we are drawing here graphs of cosec, sec, and cot. Now, understand that these are only for, frankly speaking, theoretical importance. That can we draw the graph? Yes, we can draw. But half, more than half journey of trigonometry, you will be able to complete only with help of sine, cosine, and tan. Now, if you want to see, are they also periodic functions? Then yes, cosec and sec are periodic functions. Their fundamental period is 2 pi like sine and cosine. And cot is periodic with fundamental period pi like tan. Now, these are 6 graphs, out of which these 3, I will not say they are of less importance, but you can manage with sine, cosine, tan. This is what I meant. Now, don't you think that we should be able to see some applications of these graphs? I mean, why are we drawing these graphs? So let us take short and sweet applications. The first one, what I am drawing here is on the same set of axes, cosine and sine graph. In the first part, that is 0 to pi by 4, I can see cosine graph takes upper position, and in pi by 4 to pi by 2, sine graph takes upper position. And hence, I can write in 0 to pi by 4, cos x is greater than sin x. At x equal to pi by 4, cos x and sin x would be same because that happens at point of intersection. And in pi by 4 to pi by 2, cos x is smaller and sin x is bigger. Means cos x less than sin x. Why do I say so? Because sin x graph takes the upper position. Now, I can take one more example. And here in this, I have drawn 3 graphs. One is of y equal to tan x. Second is y equal to x. And third is y equal to sin x. And I have drawn them over interval 0 to pi by 2. And what I observe is tan x takes the uppermost position, then comes x, and then comes position of sin x. Exactly same thing I'll be writing as in 0 to pi by 2, sin x less than tan x. Mind you please, if these graphs were not shown here, and had I given only those 2 first columns, where I'm writing somewhere cos x is greater than sin x in 0 to pi by 4, or maybe here sin x less than tan x in 0 to pi by 2. If you just read those statements, nothing would occur to your mind. But if you see the graph, you can see that result easily and you can understand also very easily. Remember, and that is why graphs are important. So I finish this session here. When I come next time, again, something new I will be bringing in trigonometry. Till then, stay tuned. Thank you.